Okay, hello. We are going to talk about static friction. Oops, there we go. So, what I mean by static friction is it is a force that opposes motion entirely. It does not move. So, whenever something is not moving, you're going to have static friction. If something is moving, you will have kinetic friction, which is a completely separate video. Now, we're going to go over a couple problems. Problem one is going to be very easy. It's not moving. It's at an incline. Very simple. So for problem one, I'm going to go ahead and write down the important information that you need for any static friction force. Number one, what are we talking about? For this, we're going to be talking about a 2 kilogram box. Now it's very important. We now know the mass of what we're talking about. That is our M. M equals 2 kilograms. Now, we need to know what's happening to the box. Well, it's going to be on a 30-degree incline. That's it. Now we need to find static friction. Ready? Okay, so first thing, we're going to draw out the scenario. First, I'm going to draw my lovely 30-degree incline. It's 30 degrees. Next, I'm going to draw my box. Ignore how bad the box is. Now, inside this box, I'm just going to go ahead and write down that it is 2 kilograms so we don't forget it. Okay, so in here, we're going to have to do everything else. We're first going to draw our free body diagram. So, with every object on Earth, it has gravity. Remember, gravity, force of gravity, equals the gravitational constant times the mass. So on Earth, that top constant is about 10 times its mass, which is 2, which is going to give us a total of 20 newtons for our force of gravity. Now, put that on the box. We're going to go right here from the center, straight down. That is our force of gravity equaling 20 newtons. Now, we also have force normal. Force normal is here because it is touching a surface. So I'm going to draw where it touches, and I'm going to go perpendicular to that point. So I'm going to go in the opposite direction. This is our force normal. Now, we're going to figure out force normal in a minute, but first let's draw the rest of the forces. Now, as you can see, we have a force going directly down and a force going up and to the right. To balance these forces, we're going to look at where the motion is happening. Well, the motion, if it was moving, would go in this direction. So we are going to oppose it because we're talking about friction. We're going to say it's going in this direction. Force of static friction. Now, here's what we're going to do. We are going to break up our force of gravity into 2 components. Instead of it being straight down, I want to have our force of gravity here and here, just to make it easier on us. This is just going to be something we see. We can draw a second free body diagram if we need. Now, I'm actually going to draw that second free body diagram over here. Here is our box. We have force of gravity in the Y. And here's our force of gravity in the X. Now, we also have our 2 other forces. We're going to go ahead and draw them. This is force normal. And this is force of friction. Now we got to find out what these two are. And as soon as we do that, it's equal to the other force, since there's only one force acting in both directions. So to find out force of gravity in the y, we are going to say force of gravity in the y is equal to, well, let's think about this for a second. If we had a normal box and we had a mass of 2, all of that mass would go into force of gravity. If we broke it up into its x and y components, all of it would be going into y. There would be no x. So we're going to say cosine of 0 times force of gravity equals force of gravity in the y. So the most important part here is we are using cosine because cosine of 0 is 1. That means all of it is going to go into y. Now, on our problem, it's not all going to go into y because we are at a 30-degree incline. So we're going to say cosine of 30 times force of gravity. Now, if I remember correctly, cosine of 30 is, I did sine, hold on. Cosine of 30 is root 3 over 2. We're going to go ahead, mark that out because we now have the number. And force of gravity in this problem is 20 newtons. So we're going to go ahead and write 20 newtons. Oops. 20 newtons. Mark that out. Whenever you find a value, go ahead and plug it in for the actual term so you don't have to deal with terms. Now, we're going to go ahead and simplify this a little bit. So force of gravity in the y equals, well, 20 divided by 2 is going to be 10. We're going to bring the root 3. So force of gravity in the y is 10 root 3 newtons. So we're going to go ahead and drag it right here. Equals 10 root 3 newtons. We're going to do the exact same thing for x. Now, instead of cosine, we are not going to use cosine. We're going to use sine for this one. So force of gravity in the x equals sine of the same angle, which is 30 in this case, times force of gravity. Now, force of gravity is still 20 newtons. Sine of 30 is going to be 1/2. That means our force of gravity in the x is going to be 20 divided by 2 is going to be 10 newtons. So we're going to say equals 10 newtons. Now, this makes our problem very simple because there are only 2 forces going on this axis, and there are only 2 forces going on this axis. It's going to make this extremely easy because these forces are going to balance out. So whatever F of the force of gravity in the y, that's going to equal the force of normal. Same thing on the other axis. Whatever force of gravity in the x is, it's going to equal force of static friction. Now, we already found static friction because we found our F of gravity in the x. That equals 10 newtons. We already found our force normal. That's just our force gravity in the y. That is 10 root 3 newtons. Now, there's only one other thing we have. We need to know what our coefficient of friction is. Now, our coefficient of friction is very simple to calculate. We're going to take our force of static friction and set it equal to mu force normal. This is the actual equation for static friction. Now, we're going to just redo this a little bit so we have mu by itself. So I'm going to divide force normal from both sides. And we're going to get mu equals static friction divided by force normal. Now, we're just going to divide those two numbers. That's it. So our static friction again is 10 newtons divided by our force normal, which is 10 root 3 newtons. When we divide this out, it's going to cancel the 10s, and we are going to be left with our coefficient of friction equaling 1 over root 3. Now, your teacher may not like this, so we're going to go ahead and make it a proper fraction. We're going to say multiply each, the top and bottom, by root 3. Well, 1 times root 3 is going to be root 3. Root 3 times root 3, that's going to be 3. So our coefficient of friction is root 3 over 3. Now, that's the entire problem. We have two answers. One, if we need static friction, and one, if we needed the coefficient of friction.